Goal today is to solve by elimination. You guys have already told me the definition of eliminate is to get rid of or remove. Two things. We want to make sure it's in standard form before we start. Second thing, the variable term must be a match with its other term or it won't make a zero pair. So look at our first question. 3x minus 7y equals 10 and 6x minus 8y equals 8. Would it be easier to get the y's to match or the x's? Why? Lots of right answers, absolutely. Said in lots of different ways, but you are correct. So because 3 is a factor of 6, then it will only have to change equation 1. So we'll multiply by negative 2. My zero pair, the one that is going to be eliminated, was the x. How much of the problem is done now? Good, half. So how do I get the other half? Good, plug it in. Except don't be like Mrs. Walter. Where did I just incorrectly put the negative 2? X. Where was it supposed to be? So be careful. You have two options to check it. You can solve each equation for y and plug it in your calculator, or you can check each equation with the ordered pair. So the first one worked. Came out to be negative 4 plus 14, which indeed is 10. Check the second one. Do you all know why sometimes you only had to use one equation last night to check it? Well, sometimes they were the same, but on occasion there were some that we did in the notes where I gave you the second equation was just x equals or y equals, so all you had to check it in was the one that had both x and y. Okay? I'm not sure that everybody caught on to that. And it does work, so we can feel good about we're done. We did one. We have it right. I want to talk about quickly, not take a lot of time for it, what are the possible solutions? Because obviously we can get this kind of solution, which is independent and consistent. But what other kinds of answers can you get when solving a system of equations? What if you get a possible solution, you've worked it out, and you see that your solution is 4 equals 7? What do you know? It's wrong, right? Or is it wrong? I would agree that it's false, but what happens when it's false to the lines? Parallel. There is no solution because they never intersect, and we would use our new vocabulary word, inconsistent. If we were looking just at the equations, the slope is equal in both. Another possible solution might be x equals x, or 3 equals 3. What would you say about that? Good, it was true. You'd say there were infinitely many solutions, right? That it is both dependent and consistent. And you could also say, oh, well, those are just the same line. How would you know that they were the same line? If you got both equations equal to y, the slope would be the same, and what would b be? Same in both. Because if it's the same line or the same equation, the slope and the y-intercept have to exactly match. Isaac brought up a point a minute ago that I want to call to your attention. I want you to work this solve by elimination. But if given the choice, would you solve by elimination? No. What would you use, Riley? Yeah, because it's already one of them set up, ready to go. However, because we are practicing elimination, we'll add that to both sides. Are we very close to being able to zero out x or y? Jessica, which do you want to pick to eliminate, x or y? It can be your choice. All right, so I'm going to multiply everything in the first one by -1. I'm going to keep the second equation exactly the same. And what small problem just happened? They both went away, didn't they? So what do you say about 0 equals -3? Does it mean you made a mistake in the problem? No. What does it mean when it's false? Good. Two parallel lines. And how can we prove it algebraically? Well, you've already got your y2 ready, so how can we get this guy ready? Good. My y2 is ready. And algebraically, what do you know because of the algebra formula? They have the same slope, so they're never going to intersect. You could graph them, and if you graph them for your check step, what would you see? Good, parallel lines. So that guy would hit at 4 and have a downward slope of down 2, right 1. This would hit at 1 and have a downward slope 2 over 1. That would be y2. And you could check it in this way. Either one of those ways worked. This is the algebraic check. You've used the formula for y equals mx plus b and proven they have the same slope. Or you can check it on your graphing calculator and then copy the check onto your paper. Either way, it is fine with me. But remember, at the beginning I said if given a choice, you would not choose elimination. You would choose to do it by substitution because it was already ready for that. Go ahead, Isaac. Yes, most people see it right when you write them down because they're exactly the same except for it's going to mess with the y-intercept. Absolutely, good point. But you still have to show your work and do the problem.